Welcome. The Clearwater event will start at 10 sharp. We hope you enjoy the following slides as you wait for the event to begin. Good morning and welcome to the launch event for the Clearwater Tunneling Machine. My name is Brian Langpap. I'm the Public Information Officer for the Los Angeles County Sanitation Districts, and I'll be your MC. I'm at the south end of our joint water pollution control plant, which sits at the border between Carson and Wilmington. This is where most of the construction activity for our Clearwater project will take place. We're holding today's event to celebrate an important milestone on our Clearwater project, which is being built to protect local waterways. Soon, the huge tunnel boring machine, or TBM, that you see behind me will be lowered below ground and begin a 3.5-year tunneling journey. Our program today is about 25 minutes long, and it involves a few speakers, the unveiling of our custom-built tunnel boring machine, and recognition of the finalists in our TBM naming and art contest. With me is Basil Hewitt, an engineer and sanitation district supervisor. Now, because the TBM is so big, Basil's going to introduce you to it in pieces throughout our program. After the main program, we're going to offer a virtual tour for those who want to stick around and learn more about the tunneling process or ask questions. Our first speaker this morning is Robert Fronte, Chief Engineer and General Manager for the Sanitation Districts. Robert?
Thank you, Brian, and thank you to all of you that are joining us today for this launch event. It's a beautiful day here, and it's too bad that we couldn't have this with all of you here at the site, but thank you for joining us virtually today. For those of you who don't know the sanitation districts, we are the public agency that treats over half the wastewater in LA County for over 5 million people throughout the county. We have 11 wastewater treatment plants, 1,400 miles of sewer system through the county, and most importantly, we treat 400 million gallons a day of wastewater. That's equivalent to filling the Rose Bowl up 5 times each and every day. This plant, the Joint Water Pollution Control Plant, was put online back in 1928, so it's soon it'll be approaching its 100-year anniversary, and it is our largest treatment plant. It serves over 5 million people and is the hub of our sewer system. As a result, this plant is very critical to protect public health and the environment. And the clean water from this plant after treatment is discharged out 2 tunnels that are 60 and 80 years old, and they've been in continuous operation since the late 50s. The new tunnel will make our system more reliable and protect local waterways. We expect some of the funding for this project to come from the federal level as well as from the state revolving fund, and we appreciate that funding because it allows us to spread the cost of the project over many years and keep our rates that we charge relatively low and stable. But before I move on, I want to thank everybody that's been involved in this project up to this point. A project of this magnitude isn't done by just a few individuals. Not only within our agency, it involved almost all of our departments, but a number of consultants as well, and contractors that you'll see today, as well as the City of Carson and the City of Long Beach have provided assistance to, as well as other government agencies. I would also like to especially acknowledge three people who have made significant contributions to this project and who have unfortunately passed away. For over 10 years, Tom LeBrun and Steve Heider from the Sanitation District staff led the planning efforts from the initial planning and concept for the project through the beginning stages of the public outreach. And David Yankovich from Parsons, our consultant, led the design effort for the tunnel. We appreciate their efforts and wish they could be here with us today. Investing in aging infrastructure is critical for the region and critical to protecting the environment. This is a once-in-a-lifetime type of project. We're pleased to be able to share it with you, and we're excited to be on the verge of the tunnel boring machine starting its work and starting its path towards the ocean. We now have a short project video that describes in a little bit more detail the Clearwater Project.
Hi, I'm Glenn Acosta, an engineer with the Sanitation Districts. I'm at the south end of the Joint Water Pollution Control Plant, where most of the above-ground construction for the Clearwater Project will occur. The joint plant is critical because it treats sewage for 5 million people. The plant depends on 2 old tunnels to carry treated water to the ocean. These tunnels were built 60 and 80 years ago, and there are several concerns with the tunnels. First, the tunnels cannot be taken out of service for inspection or repair because they continuously carry flow. Second, the tunnels were not built to current seismic standards, yet they cross 2 earthquake faults. Third, the tunnel's capacity could be exceeded during heavy storms when rainwater gets into the sewer system. After years of planning and community outreach, we concluded that building an 18-foot diameter tunnel was the best way to address these concerns. The new tunnel will provide reliability for a sewer system that serves almost half of Los Angeles County. The new tunnel will run 7 miles from the joint plant to Royal Palms Beach in San Pedro. And, based on community input, the new tunnel will be built almost entirely under city streets. A state-of-the-art tunnel boring machine, or TBM, will be used for this project. The TBM will be lowered down the shaft about 90 feet and begin tunneling this summer. Tunneling is expected to be finished in the year 2025 and the overall project completed a year later.
Good morning, everyone. What a lovely day to look at a tunnel boring machine. What you saw behind the podium, behind Robert and Brian, was the cutting head of our tunnel boring machine. I'm on the backside of that cutting head. If you look over my shoulder, this is the backside of the front of the tunnel boring machine. Embedded in this end, on the backside, are 7 electric motors, each 215 horsepower. They rotate ever so slowly and build our tunnel every day. They build between 30 and 50 feet of tunnel per day, and that translates to a top speed of 2 inches per minute, because this is a precise tunneling project. Another key in the front end of a tunnel boring machine, we're looking at, this is like the locomotive of a train, are these hydraulic thrust jacks, these white things here. There's 16 pairs of these, and what they do, they're all hitched together, right? Like the front end of a train. And what happens is these push off and move our tunnel boring machine forward on its 7-mile journey. So there you have it, the front of our tunnel boring machine. Think of it as the locomotive of our TBM. Back to you, Brian.
Thank you, Basil. Our next speaker is Director Kathy Warner, representing the City of Whittier. Ms. Warner first joined the Whittier City Council in 2004, and she has served as the mayor on 3 occasions. She is also chairperson of Sanitation District Number 2, which is the administrative district for our agency. We appreciate her strong interest in the work that we do here at the sanitation districts, as well as the leadership that she's provided as our chairperson. Director Warner?
Thank you, Brian. It's great to be with you all today. This is really exciting. I had no idea what to expect. It's really quite overwhelming. I've been a sanitation district director since 2005 and have followed this project since the planning days. This day has been a long time in coming. However, our very qualified staff has taken the right approach in carefully planning and designing such an important project. As Californians, we enjoy a great standard of living, in large part due to the quality of our infrastructure, such as being able to reliably get electricity or clean water, also being able to flush the toilet and have the water reliably cleaned and not degrade the environment. This project is an investment in infrastructure to maintain that standard of living and preserve the environment for our grandchildren, of which I will contribute 30. On behalf of other sanitation district directors, I'm proud to serve on the governing board of the sanitation districts, and I'm excited to see the progress being made on this important project. I also want to thank all the students that participated in the naming and art contest and congratulate those winners. And I look forward to hearing from my colleagues on the board, Joe Buscaino and Pat Fury. Thank you.
And now we're at our second location. So the first stop showed you the front of the tunnel boring machine. Now we're at the second stop. This is called the trailing gear. Think of it as housing a little city that supports the front of the TBM. And each of these segments, trailing gear segments you hear, think of them as rail cars. They will be hooked together one after another, and they will be pulled by the locomotive, the front of the TBM. So as this tunnel boring machine goes further and further along the alignment, all these trailing gears will be hooked together for a total length of about 700 feet of trailing gear and about 80 feet of the front end. So for a total length of 780 feet. So let's look closer at the trailing gear. These tubes bring in important fluids, oil, water that's needed at the front of the tunnel boring machine. If you look at the big tube at top, that's for ventilation. It brings air all the way to the front of the tunnel boring machine where the cutting head's at. And then those 2 white tubes are very critically important. One brings in a slurry or a mud, and what that does, it goes to the front of the cutting head and it lubricates the cutting head. It also stabilizes the front of the cutting head, and then that slurry is mixed with rock, gravel, and sand, and it becomes a pumpable mixture that gets pumped all the way out back to the shaft site, and then we will treat that when we bring that to the top floor. So there you have the first 2 locations, the front of the TBM, the trailing gear, for a total length of 780 feet. Back to you, Robert.
Thank you. Our next speaker is Joe Buscaino, councilman for the City of Los Angeles' 15th District, which runs from Watts to the Port of Los Angeles. The Clearwater Tunnel will go underneath his district. Councilman Buscaino first joined the City Council in 2012 and currently serves as its president pro tem. He is chair of the Trade, Travel, and Tourism Committee, which oversees the Port of Los Angeles, LAX, and the LA Tourism and Conference Board. He is also director for several sanitation districts and chairperson for 2. He is the immediate past president for the National League of Cities, where he continued to advocate for the federal government to increase infrastructure investment directly to cities, counties, and states. Councilman?
Clearwater Project is an important project to protect the waters of Southern California. This project is not only about water quality protection. The sanitation districts have also committed to hiring local workers, and as we know, this project will provide jobs and pump hundreds of millions of dollars into our economy. Infrastructure investments such as a Clearwater Project also support local jobs by making it possible for businesses to locate here in Los Angeles. knowing that they'll have good, reliable wastewater service and their workers will have a good quality of life. I also commend the sanitation districts for planning the Clearwater Project so that there will be little to no disruption to local communities, and as the bulk of the surface activity will be located at the plant in Carson. So thank you so much for having me, and I can't wait to come back for a ribbon cutting ceremony. Looking forward to that time. Thanks again.
The company we've hired to construct the Clearwater Tunnel is Dragados USA. Dragados was selected from a small group of contractors who have the expertise to do a project like this. Our next speaker is John Kennedy, Vice President of Operations for Dragados. Mr. Kennedy.
Thanks, Brian. Dragados has been building large tunnels all around the world for over 70 years. It's our proud pleasure to be working with the sanitation district on this important project. We've acquired a state-of-the-art tunnel boring machine, custom built for this project. We believe we have the right machine, we have the right plan, and definitely the right people. Soon we'll start lowering this tunnel boring machine into the shaft, where we'll complete assembly and then begin the mining progress all the way to the beach. And in about 5 years, we hope to see you all again for a celebration ceremony at the conclusion.
All right, we're here at our third and final stop of our behind-the-scenes tour of our tunnel boring machine. We're at the slurry treatment plant. In most mining or tunneling operations, there are a couple of ways of removing the soil and rock. You can have conveyor carts, rail carts, conveyor belt. For our tunnel boring machine, we're going to be using slurry, as I mentioned in the previous stop. So at this plant, we create a slurry, which is a muddy type substance. We pump it to the front of the cutting head that you see behind the podium with Brian and Robert. And that slurry mixes with the rock and the gravel and dirt and becomes a pumpable mixture. We pump all that stuff from the front of the tunnel boring machine back to the shaft site, up to the ground surface, and then in this building, we separate the slurry from the dirt, the rocks, and gravel. That dirt, rock, and gravel then comes out of this building. It's put on a conveyor belt that's loaded on trucks, taken off site. And then the slurry, the cleaned up slurry, we recycle that to the front of the cutting head, to the front of the tunnel boring machine. So there you have it, a quick 1, 2, 3 of everything you'd want to know about a tunnel boring machine. Back to you, Robert.
Thanks, Basil. Before I introduce our tunnel boring machine, I do want to thank John Kennedy from Dragados for being here. They've been a great partner on this project, and we're lucky to have them. I also would like to thank Council Member Joe Buscaiano for his support of the sanitation districts and the City of Los Angeles for their assistance in moving this project forward with their help as well. But now it's my pleasure and honor to formally introduce Rachel, our tunnel boring machine. The machine is built to slowly carve its way through soil and rock deep below the ground without interrupting our daily life in the community above. Rachel was built by one of the world's top TBM manufacturers. She was tested at the factory and then had to be disassembled and shipped to our site in pieces. When fully assembled, Rachel will be over 2.5 football fields long and serve like a small underground city. The name Rachel is for Rachel Carson, the author of Silent Spring, a book that is credited with sparking the environmental protection movement in the 1960s. This is particularly an appropriate name because the Clearwater Project is about protecting water quality, and I can't think of a better environmental hero to honor as a namesake for the tunnel boring machine. The name Rachel came from a student naming contest. The winner and other finalists will be recognized in our next segment.
In our next segment, Torrance's Mayor Pat Fury will introduce the finalists of our TBM Naming and Art Contest. Mr. Fury first joined the Torrance City Council in 2008 and has served as the city's mayor since 2014. He's also chairperson on 2 sanitation district boards. Mayor Fury is a voting delegate on the National League of Cities, and he is chairperson of both the state and federal legislative advocacy committees. Mayor Fury.
Hello, everyone. I'm Torrance Mayor Pat Fury, and I also serve as a director to the Los Angeles County Sanitation District. It is my privilege to recognize the finalists from the Clearwater Tunnel Boring Machine Naming and Art Contest, which were open to all Los Angeles County students. Naming a tunnel boring machine is an ongoing tradition that dates back to the 16th century. So for this contest, students were invited to submit a short essay explaining why their name should be chosen. I'm here with the finalists for the naming contest. This contest was open to all students from elementary through high school. Many creative names were submitted, but here are our finalists. Starting with third place, there was a tie between Angelica Ruiz and Lucas Chen. Angelica is the 7th grade at Thomas Starr Middle School in Los Angeles. She suggested the name Alicia, which means helper in Greek. Great idea. Lucas Chen, a high school junior at San Marino High School, nominated the name Ruth after Justice Ruth Bader Ginsburg. Very timely idea. Second place went to Nathan Membrano. Nathan is a 7th grader at Thomas Starr Middle School. Nathan's nominee was Wiley, a combined name for William Lindley, who invented the modern sewer. I think that's kind of appropriate too. But first place went to Hannah Sue, a 5th grader at Highland Oaks Middle School in Arcadia. Hannah suggested the winning name Rachel, after Rachel Carson, who actually sparked the environmental movement with her 1962 book, Silent Spring. You can read all the essays at www.clearwater.lacsd.org. Great job, all of you people. These were all fantastic options. Thanks for participating. There were also art contests for elementary, middle, and high school students. For each contest, students were asked to submit original artwork that shows why it's important to keep our rivers and oceans clean. You can also see all the artwork from the finalists at www.clearwater.lacsd.org. I'm now with the finalists of the elementary school art contest. Third place went to Dahlia Bain, a 5th grader at Da Vinci Connect School in Hawthorne. Her winning artwork is shown on the screen. Her artwork focused on the beauty of marine life. Second place went to Aaron Bain, also a 5th grader at Da Vinci Connect. You can see he drew the TBM, happy to be surrounded by marine life. First place went to Dagny Tang, a 2nd grader at Matamalaga Elementary School in Palos Verdes Estates. Dagny's artwork focused on the importance of water to our planet. Congratulations to our elementary school finalists. Dahlia, Aaron, and Dagny, you all did a great job. Give yourselves a round of applause. I'm now with the middle school art contest finalist. Our third place winner is Natalie Ezadijian, a 7th grader at C&E Mardinian Armenian Evangelical School in Sherman Oaks. Natalie's art is a reminder of what can happen if we don't take care of our oceans. Second place went to Valeria Mendoza, a 6th grader at Wallen L. Andrews School in Whittier. Her art focused on the Clearwater Tunnel protecting marine life. And first place went to Ashante Perez, a 7th grader at Thomas Starr Middle School. She reminds us why we need to protect our oceans. Ashanti, Valeria, and Natalie, thank you so much for participating and submitting your artwork. You all did awesome. Congratulations. I'm now with our last group of students to recognize today, the high school art contest finalists. Third place went to Alana Cho, a sophomore at Palos Verdes Peninsula High School. Alana's artwork shows us the impact that littering can have on our marine life. Second place went to Lauren Shin, a senior at West High School in Torrance. She also illustrated the impact of not protecting our oceans. Our first place winner is Amelie Tyler, a senior at Palos Verdes Peninsula High School. Amelie's art piece is a great reminder of why we need to protect our oceans. Folks, I'm really impressed by the work of all these students, Alana, Lauren, and Emily. Thank you all for your thought-provoking artwork. Congratulations. I actually want to thank all of the students who participated and made the contest a great success. Your interest in the environment gives me hope for the future. The Clearwater Project is an important project to protect our waterways, and I'm very happy to see it moving forward. So thanks everybody for being here today.
Thank you, Mayor Fury, for your support, and thank you for doing a great job with those kids with the artwork and the naming contest. Thank you very much for your support. And here is the artwork that is along the side of our tunnel boring machine. You can see the winners of the contest, and you can see, of course, we thank Hannah for coming up with the name Rachel. Hopefully this artwork, along with the Rachel name, will give us good luck as we make our 4-year journey to the coast and leads to a successful outcome. Once again, we'd like to thank not only the winners, but all the kids that contributed and submitted drawings and names for the project. All of them were very creative and original. Thank you.
Thank you to all the children that participated of all the grade levels. We really appreciate your participation, and particularly Dagny, Ashanti, Emily. Congratulations on having your pictures on the side of this awesome machine. Thanks again.
Well, that concludes our main program this morning. On behalf of the sanitation districts, I want to thank all of our speakers. To find out more about the tunneling process, stick around for our virtual tour, which is up next. You can also find out more about the project using the information shown on your screen. Thank you for joining us this morning. Now I want to hand things off to Russ Vicaria for the virtual tour. Russ is a supervising engineer in our construction management group. He and his team are working closely with Dragados to make sure that the project is a success. Russ, take it away.
Hey, thanks, Brian. And good morning, and thanks everybody for joining us. I'm going to give you a little brief overview of the tunneling process. And if you have any questions, please use the Q&A feature in Zoom during the presentation, and then I'll take questions at the end. So as was discussed at the presentation, the TBM ceremony was held today where this yellow dot is, and the new tunnel that will be constructed is this green line. It's the existing tunnels are shown in purple. You can tell that the new tunnel has a lot more curves in it, and that's to remain under public right-of-way to minimize going under any private property or other things per public request. So this is a 7-mile tunnel, $630 million construction cost with over 30 curves going all the way from our treatment plant in Carson to Royal Palms Beach. So the starting point of the tunnel, which Glenn talked about earlier, is the tunnel shaft. And here's the shaft site. It's an aerial view. The TBM ceremony you just saw was held in this location on the bottom left-hand corner. To give you some bearings, here's Figueroa Street on this side. Here's the Harbor Freeway. And the shaft that the tunnel machine is going to be lowered into is shown right here. And the tunneling will go in the direction of this yellow arrow. So as Basil showed you during this presentation, we've got the front of the tunnel machine here on the bottom left-hand corner. The trailing gear is in the right side in this location. And then the slurry plant that'll support the tunneling is shown here. And I'll go through some of those in more detail. So in general, the point of the shaft is to launch the tunnel machine. So here we have a side view of the shaft. Here's the ground surface. The groundwater level is here. So you can tell that we're going to be putting the tunnel machine well under groundwater. The total excavation for the shaft was 135 feet approximately. So the point of the shaft is to lower the tunnel machine into it and then to begin tunnel mining. And here's an overview, an overhead shot of the shaft that was taken a few weeks ago. So the route of the tunnel, and it was discussed a little bit, but just to recap, here's an aerial shot. The tunnel shaft where we had the ceremony this morning is shown at the bottom. Here you see the Harbor Freeway, Royal Palms Beach in the distance, Catalina Island beyond it. And so the tunnel route is shown with the yellow arrows. So we come out of the tunnel shaft, and then the tunnel machine will head south on Figueroa, go right through Harbor Park, under Machado Lake, onto Gaffey, and then beyond. So the overall overview of the route is shown here. So here on the left side, we have the Carson shaft, where the tunnel machine is going to start. On the right side, you see the exit shaft at Royal Palms Beach. The ground surface is shown above. The tunnel route is pretty flat, but you can see the ground surface changes a lot. So the first half of the alignment is about 45 to 90 feet deep. And then the second half, we get as much as 460 feet deep under the Palos Verdes Peninsula. So again, we start on Figueroa Street, go through Harbor Regional Park, onto North Gaffey, then Capitol, then onto Western Avenue, Dodson, back to Western, and then to the Royal Palms Beach site. So again, here's a similar diagram. It's just colorized. The tunnel route is shown with the red dots. Here we have on the left side, the Carson shaft, the starting point, and then the exit shaft on the right side. And the groundwater is shown with the blue line. And you can tell that the groundwater is here. So we're under groundwater the entire way. And all the different colors you see on this section are different types of ground. So this tunnel machine has to be versatile enough to handle all those different ground conditions. So in summary, this 7-mile route, the first half is soft ground, but it's different types of soft ground. The second half is made up of rock. So again, if there was some intermediate shaft, the contractor could have even chosen to use 2 separate tunnel machines because the ground conditions are so different. But because we're going from one shaft, this tunnel machine has to be versatile enough to handle all these ground conditions. So let's talk about the tunnel machine itself. Now, in the past, a lot of tunneling that's been done in Southern California and elsewhere, both by the sanitation district and by other agencies like LA Metro, were done with tunnel machines like this. They were just very simple shells with a digger arm in front. In fact, a lot of the subway tunnels in downtown LA were dug using machines like this. And the analogy I draw is this sort of machine is like a VW Bug. It's very simple, it's functional, it's lower tech, it's inexpensive and easy to maintain. And if the conditions are correct, it's a very effective tool. But this job involves numerous challenges that require a more advanced tunneling machine. First of all, we've got 7 miles of tunnel with 30 plus curves from one shaft. And if you look at a lot of the other local tunnel jobs going on in LA, many of them are straight 1 to 2 mile long tunnels. So this is considerably different. The ground also varies on this job from soft ground to rock, and there are numerous subcategories within these. So really, you have one machine doing the job of 2 that has to be able to handle all these different conditions. The entire tunnel is also below groundwater level, so the tunnel machine has to be able to handle significant earth and water pressures and squeezing ground along the way. So here is the tunnel machine. You saw it a little earlier today. It was fabricated at Heron Connect factory in Germany, which is probably the premier TBM manufacturer in the world. It was put together and factory tested, then taken apart and shipped to the site. The diameter of the tunnel machine is about 21.6 feet. So it's like a 2-story building plus. The whole head rotates, and then you've got various cutting tools on the head that help dig the ground. So here's the front of the tunnel machine as it was assembled in the factory, and it pulls along this trailing gear behind it, which Basil talked about earlier. And again, as he mentioned, this trailing gear is like a moving underground city. It's got to support the entire tunneling operation, the materials, the personnel, the safety issues. So it's got ventilation, power cables, transformers, pumps and piping, sensors, safety equipment, and much more. And one of the things it carries is a control cabin where the TBM operator sits. and looks at various screens. This is a very sophisticated machine, so it throws out a lot of data which the TBM operator has to watch and make adjustments as needed during the tunneling process. So to give you an idea of how long this tunnel machine is, and it was stated a little bit in the presentation, but here we've got SoFi Stadium where the Rams play. We know that a football field is 300 feet long, 100 yards. So if you superimpose the tunnel machine on it, it not only stretches one full football field, it really stretches more than 2.5 football fields. And so it's over 750 feet long, and it was delivered to the job site in over 90 truckloads and then put together. So again, as I mentioned, the way the tunnel machine works, the rotating head turns. You have various cutting tools that help break up the ground. You've got a rock crusher that looks like this at the bottom, which crushes up any kind of rocks that come into the cutting chamber. And as was discussed again, here are the thrust jacks, and this is what moves the machine forward. So you've got 16 double pairs of thrust jacks, and when they extend, they push the machine forward, and that's how it's propelled forward. So here's a basic video of the tunnel machine and how it operates. So what you'll see is the head turns, the excavated material come into the cutting chamber. The machine is pushed forward by these jacks, and the jacks push forward on the last erected concrete ring that the tunnel machine erected. And each ring is comprised of 6 pieces, which are called segments. So you'll see the tunnel, the head moves, the jacks are pushing the machine forward, and then each jack retracts, and you'll see a new ring being constructed. And then once the ring is constructed by the tunnel machine, then it'll push off again, and that's how the tunneling process works. So these tunnel segments and rings are being produced in a facility in northern LA County. Here's one of the molds used to fabricate it, and the arrows show where the tunnel ring sits inside, the tunnel segment sits inside the mold. And here's a picture of the mold with the top open. Reinforcing steel is put in here, or fibers, and then concrete is poured, and it's a highly mechanized line. So you see the robots doing some of the work and people doing the rest. So this fabrication process is just starting right now. So here's a picture of some similar tunnel segments from another job. So once the tunnel segments are fabricated, they'll be trucked to the site, and then they'll be brought to the tunnel machine through the tunnel using a carrier like this. And this sort of carrier not only brings segments, but it brings other material. It brings personnel to the front of the tunnel machine and materials. So while the tunnel machine is working, it's important that we monitor the ground to make sure the tunneling process is working properly. So here's the tunnel machine moving along. So we have ground settlement points throughout the alignment. So if there's any movement in any of these points, we see it in real time on our cell phones or computers. But we don't only want to monitor the surface, we also want to monitor underground, because by the time an issue may move its way to the surface, it takes some time. So we have these underground settlement points, and you can see that the bottom point is right above the machine. So we can detect any kind of ground movement underground. And again, this information we see in real time. We also have utility settlement points that are placed on various utilities throughout the alignment, and also vibration and noise monitoring sensors throughout the alignment. So all these sensors, whether they're underground points, they're structure points, they're ground points, they transmit their information wirelessly to these total stations, and then these transmit the data to, again, our cell phones, our computers, so both the contractor and the district have this information in real time, and the TBM operator does also. So any adjustments that need to be made can be. Here's a screen from another tunnel job, and this is sort of the tunnel machine moving forward, and the green dots are various sensors. So again, if there's any movement in any of these sensors, it's relayed immediately to our cell phones or computers, and we'll have a similar sort of setup on this job. So that's the ground monitoring, but we're also monitoring the data that comes off this tunnel machine. So this tunnel machine is very sophisticated, has a lot of equipment, and the tunnel machine is constantly generating data on the tunneling process, such as the excavated quantity, the thrust force, cutting tool wear, pressure, and many more. And so there's a fiber optic line that runs from the tunnel machine to a server on the surface. And so all this data is being transmitted in real time. And again, it gets sent to computers, cell phones, it's backed up on a server. So in this way, the contractor and the district can monitor the tunneling operation constantly and make sure it's going well and make any adjustments that are needed. So the operations and maintenance of the tunnel machine are also important. As the tunnel machine digs, there's a variety of cutting tools that I'm showing here. There are tool wear indicators also that show when some of these tools may wear out. And so these tools have to be regularly inspected. Some may have to be replaced. And as we go through different ground conditions, some of the tools are changed depending on the ground condition that we're going through. So in general, here's a very simple cross-section side view of the tunnel machine. Okay, so here's the cutting head and the tunnel machine's moving from right to left. Here's the outside of the tunnel machine. So you've got some earth and water pressure pressing up against the front. And so slurry is pumped in, as Basil mentioned, and it's a bentonite slurry. It's like a mud, and it's pressurized in this chamber. And so the idea is to match the pressure from the outside with pressure on the inside so that you don't have any kind of ground settlement. And then as the tunnel machine digs, material comes into this chamber, and the slurry and dirt combination come out through this yellow pipe, and they're sent to a separation plant where the slurry is separated, the bentonite separated from the dirt, and then the slurry is recirculated back to the tunnel machine. So Basil was standing right here, and he mentioned during this TBM ceremony that this is part of the slurry separation plant. So once the bentonite slurry has been separated from the dirt comes onto this conveyor, and then it's loaded onto trucks and hauled away. So there's also another important thing that needs to be done, which is inspecting the cutting tools. So the way the cutting tools are inspected is that you have this pressurized chamber. So all the slurry is drained from the chamber, and then air is placed in this chamber under pressure, because you still want to equalize the pressure between inside and outside the tunnel machine. And then personnel make entry using breathing apparatus into this because you've got pressurized air, and then they can inspect and replace the cutting tools and alike. This is a picture of inside the tunnel machine. So these pressurized chambers are like deep sea diving chambers where the person goes in here, closes the door. There are multiple doors they go in through. They have the breathing apparatus. And as you can probably gather, this is a very expensive and time-consuming operation because you've got to have decompression chambers on site, medical staff available just to monitor the people and that sort of thing. This sort of intervention can be done at any time during the tunnel drive, but we've also put in 3 planned maintenance stops, which makes maintenance and checking of the machine easier at these planned areas. So in 3 areas along the alignment, the contractor has pumped grout, which is like a cement mix, into the ground and created an underground block. And then what happens is the TBM, the tunnel machine, drives into the block, and then it can be depressurized. So you don't need all the breathing apparatus and all that. You can breathe normally, come into the chamber and check the tools. So to show you, again, here we're at the tunnel shaft site. The yellow arrows are the tunnel alignment, and the blue rectangles are the 3 maintenance stops that have already been built. 2 of them are underground at Harbor Park, and one of them is on North Gaffey Street underground. Here's a picture of one of the maintenance blocks being constructed. This is the one in Harbor Park, and the tunnel machine will come across Harbor Park under Machado Lake and stop in this maintenance block. This site has been restored. This is just a picture from a few months ago when the construction was going on. So as I said, these 3 maintenance blocks are already complete. So the general project timeline, we're here in April 2021. The tunneling is going to start in the middle of this year. And then we've got 3.5 years of tunneling. And then there'll be additional work, structures work at Royal Palms Beach and elsewhere, which I haven't covered in this presentation, but we'll go over in other presentations in the future. So if there are any questions, we can take them. working with me to answer these questions are Glenn Acosta, who's a senior engineer in our public information group, and Maria Rosales Ramirez, who is also a senior engineer in our public information group.
Thank you, Russ. I'm very excited to start monitoring the questions. You actually have quite a few lined up, so there's a lot of interest out there. So let's start with the first one. How is tunneling different from fracking?
You know, fracking, I'm not an expert on fracking. This tunneling process is very safe. We're not injecting any kind of chemicals into the ground or anything like that. The only thing is the slurry, and then you've got a digging process. So there should be no contamination of anything. And as I said, I'm not an expert on fracking, but we're not using any kind of explosive means or injecting any kind of harmful chemicals into the ground while we're tunneling.
Thank you. Oh, I forgot to mention, this presentation is being recorded, and I've put in the chat the link to our website and also our Facebook page for the project. So you will find a link to this later if you didn't hear your question right now. Second question, Russ. You mentioned that the existing tunnel crosses a fault line. How did you avoid that for this tunnel, since it looks like it follows a similar trajectory?
This tunnel will also be crossing the fault lines, and it's designed by structural engineers to be able to handle any kind of earthquakes. One of the reasons this tunnel is being built is because the existing two tunnels were built a long time ago and they were not built to earthquake standards. This one is. So once the tunneling is done, we're going to insert a steel liner into the tunnel and grout it in place where it crosses those earthquake faults. So it's designed to withstand earthquakes, unlike the two existing tunnels. And that's one of the main reasons we're doing this job.
Thank you. Next question is, what is the slurry made of?
It's a clay. It's bentonite clay. And so that's basically what it's comprised of.
Thank you. Next question. Where are the solids removed from the tunnel being disposed of? Are they being reused?
So when you say solids removed, I assume you mean that when we send the slurry and dirt mixture to the separation plant, the dirt is separated out. The dirt is hauled on trucks. It's the contractor's responsibility with the dirt haulers to determine where the material should be clean, so it can be either disposed in a disposal facility, or if there's some big construction job someplace that may require earth and they're able to use it for that, they can do that. And as you can probably believe, over a 3.5-year period where we're tunneling, people may have different needs for dirt. So that's up to the contractor and the dirt hauler to determine where that material will be taken.
Thank you, Russ. Next questions. How is the machine powered? How much power does it use? How is the power sourced? And what is the effect on the rest of the grid? As a percentage of the grid, it's not that large an amount of power. There's a substation on site. It's an electrically powered tunnel machine. So there's a substation on site that feeds the power to the tunnel machine. It's run along cables, and they'll be extended as we go further into the tunnel. And so there should be no impact on the grid, because as a percentage of the total, it's relatively small. The substation is 10 MVA, if that means anything to you, and that should be sufficient to power the tunnel machine for the entire duration of the job. Thank you, Russ. All right, the next question is from Renee. What can the residents who live right around this area expect as far as noise, air particulates, odor, and vibration?
In general, we've been on site for a couple of years, and we've dug an access shaft. We've done quite a bit of work. If you live around there, my phone number is always available. So if you happen to detect any kind of noise, vibration, odor, you can always call me. The tunneling process, we do monitor it closely with noise and vibration monitors. We don't anticipate that the public will experience much of anything. But if you do feel that you are experiencing anything, feel free to give me a call and we can discuss it. I'm always available to take anybody's phone call.
Thank you. And again, I've put the project website on our
on the chat, and you can contact us that way, and we'll make sure that Russ gets your question. These two questions are kind of related. You may have covered, what is the risk of inducing earthquakes?
As far as I know, and again, I'm not a seismologist, I don't see any risk of triggering any earthquake. This, as a percentage of that fault, is a relatively small bore across that fault. So I'm not aware of any risk of that sort of thing happening.
Thank you, Russ. Next question is, how was the ground in the shaft verified to not contain materials that might be difficult to bore through, like abandoned pipes or other old building debris?
So I'm assuming that you're talking about not only the shaft, but the tunnel alignment. So before the job is bid, the district hires a geotechnical consultant, and we do borings at the shaft site and every few hundred feet along the alignment. And that dirt is removed. All the contractors who bid on the job had access to that, and they based their bid on that. So that's the exploration we did, before the job started.
Thank you. Next question is, does the tunnel actually run uphill? Is it only downhill or straight?
It runs uphill very slightly, but it's such a small slope that it's really imperceptible. But technically, it does run uphill slightly from the shaft to Royal Palms Beach.
Thank you. Next question. Oh, this one is also related to the seismic retrofits of the tunnel. The tunnel crosses two earthquake faults. Are the concrete rings there beefed up for extra strength?
As I mentioned before, the concrete rings are very solid. They're made for seismic standards. But where we cross the earthquake faults, we have a double layer of protection, which is after the tunneling's done, we put a steel liner inside the tunnel where it crosses the faults, and we grout it in place. So that's extra reinforcing for when it crosses those faults. So this tunnel will be far more earthquake resistant than the two existing ones, which were not designed to that standard.
Thank you. This question is from Frank and Yvonne Locke. Where can we see a map of the tunnel route? I know that we have a map that's on your presentation that's also posted on our website, but you can check the link on the chat, and that will show you the map as well.
Yeah. And if you feel like you're not seeing enough detail, give me contact me, and I can give you more detail. We have detailed drawings showing every foot of the alignment and where it goes.
Next question is, I'll just read it. It says, I'd like to know what's the tunneling process when it approaches the sea at the end of the alignment so that the water can be discharged, and what type of shield tail sealing system will be used during the excavation?
So basically, this tunnel machine is going to be underground water the entire way from the shaft to Royal Palms Beach. And we're not actually going beyond the beach for this. We're tying into the existing outfalls on the land side of the beach. So there will be an excavation done there. We'll basically finish the tunnel. It'll be tied in. This tunnel machine is custom built to handle very significant water pressures throughout the job. And as you can see from one of my slides, if you want to go back and take a look, under the Palos Verdes Hills, there's quite a bit of water underground. So this machine should be able to handle it. There shouldn't be any issues with that. And then once that's tied into the outfalls, then we'll do the excavation and the construction at Royal Palms Beach. And that'll probably be the subject of a different presentation where I can go through that plan in detail.
Thank you. This question is from Brian. What is the quality of water at the outlet at Royal Palms? I'd like to surf there and enjoy the environment. Will the discharge be at the shoreline or hundreds of feet out into the ocean?
So just to be clear, the district already has outfalls that are discharging treated wastewater, and it's treated to a pretty high standard that's going out into the ocean. So this new tunnel is not going to add any additional flows. What we're doing is the reason we're building this tunnel is because the two existing ones were not built to seismic standard, have not been inspected. So there's not going to be any additional discharges to the ocean resulting from this tunnel.
Thank you. Next question is, how will Rachel counteract the incoming water from the last station to be opened?
the last station, I assume you mean as we're getting closer to the ocean. And again, this tunnel machine is able to handle very significant water pressures throughout. So we don't anticipate any issues with the tunnel machine being able to handle water throughout this. And one of the reasons the contractor chose this type of machine and designed it this way is precisely to handle the significant water and earth pressures that are along this entire alignment, not just at the beach, but along the way.
Thank you. Next question. This question is from Diana. How many underground monitoring points have been installed in relation to the length of the excavation?
So the underground monitoring points, it varies, but they're generally about 300 to 500 feet apart, the underground points. And then we'll have surface points that are even more closely spaced, along the alignment. And our primary area of installing those is where the tunnel is shallow. Once it gets deep, we're so deep that there's really no risk of any kind of movement on the surface. And we don't anticipate it even in the shallow area, but that's roughly, they're like 300 to 500 feet apart in the shallow section.
Thank you. Next question is, what distance is expected to be built per day?
So the contractor's schedule shows that, something like 40 up to 50 feet a day, that's an average. It's going to vary a lot. The machine will also be down at times for maintenance, for checking the cutters, things like that. So it's going to vary over time, but that's kind of a rough average per day.
Thank you. This question is from an anonymous attendee. Why didn't you take advantage of gravity by having the elevation of the outfall point at Royal Palms be lower than the Carson sanitation point?
That gets into hydraulic issues. But when the tunnels were designed, all that was taken into account because a lot of it depends on tides at the ocean and the back pressure you get in the tunnels. So it was specifically designed, to drain back to the plant. And also while we're tunneling, if we run into any water, it'll also be flowing back. So there was a lot of hydraulic studies that went into that. If you're interested in further details on that, feel free to contact me and I'll see what other information I can get you.
Thank you. This question is from Craig. He asks, how many human personnel will work underground?
It's going to vary because you've got a tunnel crew and, let's say you have 10, 15 people underground, but you also have the crew who's bringing materials and supplies to the tunnel heading. Then you've got other people up top who are handling segments, dirt, that sort of thing. So there's many different people involved in the tunneling process, but there'll be a certain crew underground. There'll probably be 10 to 15 working in the tunnel, plus a lot of other people on the surface supporting them and working in and out.
Thank you, Russ. Alana asks, do you have a camera at the head of the TBM to see if there are fossils?
This is a sealed off machine. So from inside the machine, you cannot see out into the dirt. So even if there was a camera at the heading, all you're going to see is the machinery inside the tunnel. And one of the reasons we have this machine is it's completely sealed off to the front. So there's very little potential for gases migrating in, for water and earth. So you wouldn't really see anything even if you had a camera at the heading.
Thank you. Next question is, how does the tunnel machine make curves?
That's a good question. So the tunnel machine has an articulating head. So, and again, if you want some more information, contact me, but it's not rigid. It can actually turn and then the jacks push off, but the tunnel machine will turn to make that curve. And then the segments are built in such a way that you can rotate them so that you can create segments around that curve. It's a very interesting process. Again, if you want more information, give me a call and I can give you some more diagrams or pictures of that.
Thank you. Next question is, what happens to Rachel when the tunneling is done?
That's an often asked question. And, tunnel machines are specialized pieces of equipment. Some of them are reused. Technically, the district pays and owns for the tunnel machine, but at the end of the job, most likely, some equipment will be salvaged from there. There'll be also material that probably can be sold and scrapped. The district probably has no use for the tunnel machine when it's done. And it's possible some of these tunnel machines are reused at times, but you got to find another tunnel that's this exact diameter to use. So again, a lot of it will be scrapped or reused, either scrapped for material or reused in another tunneling process. But this machine, after it's gone 7 miles, we'll have to see, what is available to reuse and what needs to be scrapped.
Thank you. A question comes also is, how many staff work at the site to monitor Rachel?
I'll put it this way. There's quite a few, the district has tunneling consultants who we've hired who are monitoring the tunnel machine. Obviously, the contractor is primarily responsible for that. This is going to be a 3-shift daily operation. So they will have people in their office up top monitoring the machine constantly. And again, now with cell phones and all, even if people are not on site, all the key personnel on the project, both from the district side and the contractor side, will have cell phone and other access. So if there's any issues that arise, you can get alerts on your cell phone. So in addition to the people who are directly on site monitoring it, all the key project personnel, even if they're home at night, will also have access to that, including myself, and we'll be getting those alerts all the time if there's any potential issue that arises.
Thank you. Oh, I like this question. Danny asks, will there be a chance for anyone to go down and look around inside the tunnel?
It is an interesting operation. I'll have to discuss that with the contractor to see what may be possible in terms of tours. There are obviously safety issues with going down there. So we'll have to discuss that and we'll let the public know if there's any potential for that in the future. But certainly at a minimum, we'll take a lot of very good photos and videos that will be available of the actual tunneling process that people can view.
Thank you. Next questions may actually be for me. It says, how many industry schools were invited to participate in the contest and the tours of the facilities? All our tours are free to all LA County, to all of LA County, and our contest was promoted to all students in LA County last fall. So next question is, Martha asks, do I understand that one driver at a time moves the drill forward?
Well, put it this way, you have a control cabin like with any sophisticated piece of equipment, some of it's automated. You do have a TBM operator there. It's not necessarily that it'll just be one person. There's one primary person involved, but there's other people involved in the tunneling process that'll make decisions regarding it. But you have one primary operator. And again, it's not like they're using, this is a mechanized process also. So there's a lot of computer control involved too. But there's one person who'll be primarily monitoring with other people involved in the process.
Thank you. And actually, this question, they're kind of tied together. Is will there be any internship opportunities, and how many jobs will be created by this project?
Put it this way, this project has committed to and has a requirement that the contractor has to hire a certain percentage of people from local zip codes, and the contractor has been exceeding those goals so far. So that's monitored all the time. So there are often apprenticeship and other opportunities. The contractor is always reaching out to the community to see who might be available to work on the project. And again, they've hired a very high percentage of people from local zip codes, as is required on this job.
Thank you. You're almost there, Russ. Keep going. This TBM is highly specialized and built in Germany. If a part breaks, how do you get the replacement part? And what is the experience of other users of equipment from this fabricator with regards to support to their equipment?
Very good question. So this company, Heron Connect from Germany, has also supplied tunnel machines to some of the LA Metro jobs that are local. And actually, it's kind of unique, but we have multiple tunnel jobs going on in the LA area. So parts, the contractor always stocks certain parts that they need that they feel they may need on a regular basis. Aaron Connect has their personnel who are available. Many times they're on site to troubleshoot issues. And if there are any parts that are needed, some of them can be air freighted if needed from overseas, but everybody knows that there's an expensive and involved tunneling process. So there's always contingencies for parts and other things available because you don't want to have a part issue slow down the job. Now, obviously, if there's some major part that's needed, it might take a little longer, but there's always planning done, and the contractor's done a lot of planning to try to minimize that potential.
Thank you, Russ. All right. I'm going to give Blake you a little chance to drink a little bit of water. There you go. Let's see. Have the cores from the geotechnical testing be saved? It is so unusual to have such deep cores that they would be valuable for geologists.
The cores have been saved. They're actually on site here in a trailer.
Thank you. Next question is, how much is the expense for this project? So TBM, tunneling, segmenting, etc. And this kind of ties to the next question is, what is the cost per foot and mile aside from the cost of the TBM on the trailing group?
Put it this way, the total construction cost, and there are obviously other non-construction costs, but the total construction contract is $630 million. And then you could do the math over 7 miles, but the tricky part is this job is not just tunneling. There's probably $100 million plus of structures that have to be built on this job, both to tie the tunnel in at the plant and also at Royal Palms Beach. So, contact me and, we could do a rough back of the envelope calculation in terms of how much cost per foot it is, but that gives you a general idea. You take the 630, maybe you subtract out 100 to 130 million, and then you can divide it by the number of feet.
Thank you, Russ. Diana asks, what is the maximum earth / groundwater pressure that the TBM will be bearing along the route?
So this TBM pressure is measured in bar. So we expect to encounter 3-4 bar worth of pressure, but this TBM is able to handle significantly more than that because you always want a factor of safety above that in case you run into other conditions.
Thank you. This one's for you. How does the CM inspect the tunnel work underground?
So we will have at least one inspector, probably 2 in the tunnel machine at all times when tunneling is ongoing. We'll also have an inspector up top. So they will be involved in inspecting that work. And up top, when segments come in, we'll be checking them to make sure that those reinforced concrete segments are good. When dirt is hauled off, we'll be checking that also, and any other work. So there'll be multiple inspectors, but there'll be at least one in the tunnel machine at all times and one above ground.
Thank you. Next question is from Jim. Is there a maintenance site at the fault line? What is the design motion on the Newport Inglewood fault or others?
I'm not sure. I'm not a seismologist, but when we're mining through those faults, there should be no issues. Again, we do put the steel liner in as it crosses. After we cross the faults for additional structural integrity. If you're interested more in details, again, contact me and we can talk further about the specifics of it.
All right. Thank you, Russ. The inspection point on North Gaffey has caused some closures to the street. Will there be any closures or lack of access to Royal Palms or other recreation areas?
One of the requirements of this job is that beach access is maintained at Royal Palms Beach. So that is the plan. And as we get closer to Royal Palms, the work there is still multiple years away. The contractor is still developing their detailed plans. And so we'll share that with the community. We'll have meetings for sure. And anybody can ask questions. But one of the requirements in our contract is that beach access be maintained at all times. Obviously, there will be some construction traffic there, but we're to maintain beach access at all times.
Thank you. Craig asks, what kind of remote monitoring will remain in the finished tunnel? Any public or educational access planned?
Once the construction's done, and after a certain period of time, we'll be removing the instrumentation and all in place. I'm not aware of any other kind of monitoring inside the pipe, but if there's something specific you're asking about, again, feel free to contact me and we can talk further about it.
Thank you. What type of shields? Oh, did I answer? Okay, there we go. What type of shell tail sealing system will be used during the excavation? Will it be using sealing grease injected at the tail skin?
So it's somebody who knows something about tunneling. So basically, I didn't go through all the details, but as the tunneling occurs, there's a slight gap that's between the tunnel machine and the dirt, and so that is that. So there is a grout that's pumped in there to seal that, and there's tail skin brushes there to prevent water from intruding into the tunnel machine. That's kind of a specialized question, but if you're interested in the specifics of that, how those brushes work and how that grouting system works, again, call me and I can, send you some more information about that.
Thank you. Next question is from Martha. When it becomes functional, does the water fill up the entire tunnel?
The water, it's going to vary quite a bit depending on the tides and the discharges from the plant, because depending on the tide and also how much water is coming out, the level is probably going to vary in that tunnel. And again, if there's a very heavy storm, then you're going to get significant pressures through that tunnel. So it's going to vary a lot.
Thank you. Next question is, how far below ground surface is the tunnel going under Machado Lake and other places where the tunnel is not very deep?
At a minimum, in that first half of the tunnel drive, we're a minimum of 45 feet deep. We're usually at least 50, 60 feet deep. And to give you a general idea, we did a tunnel on Lomita Boulevard in Carson a few years ago. That tunnel was 20 feet from the top of the tunnel to the street. This one is usually at least 50 to 60 feet deep, and through the PV hills deeper. I think I can't recall in Machado Lake, but it's probably at least 50 to 70 feet deep, but I can check that and let you know, but it's roughly that.
Thank you. You're almost there. You're less than 5 questions for us.
It's good to get questions. People are interested, right? So.
All right. I'm just going to read it the way it says. It looks like the tunnel starts deep and slopes upwards towards the ocean. Is there a reason for the tunnel draining back towards the joint plant?
Yeah, there's various reasons for that. There were hydraulic studies done on that. And again, if you contact me, I can give you further information on that. But the slope is very slight. I mean, it's imperceptible. It's exaggerated on that drawing, but overall, it's a very, very slight slope.
Thank you. Okay, I'll read it the way it says. I heard him say that there would be no additional flow of treated wastewater into the ocean. He actually said that the outfalls discharge a significant distance out. I missed it. I think this is just a comment. Yeah, we do. The outfalls are quite ways out, right?
Yeah, the outfalls are way out. And again, this tunnel is just tying in to our outfalls on land. This tunnel is not going to go under the ocean at all. So those pipes that are going under the ocean floor that are existing there, those will remain the same. That will not change. So all this tunnel will do is take the flow that's in the 2 tunnels that are going from the plant to the beach and divert it to this new tunnel. It's not going to put any new flow of treated wastewater into the ocean.
Thank you. And that actually ties into one of our next questions is the tunnel starts at 130 feet or underground, and it will end up at sea level. How does it work? How does it work to function at the end? The discharge gets pumped uphill to the end. When in the eventual use, what happens if there's equipment failure and the treated water backs up flowing downhill to the plant?
Yeah, there's, again, I can give, those are like operational issues. And if you're interested in that, give me a call. We're always, our pumps run at different times at the plant, and we've never had issues discharging. There should be no issue. And at the beach, there's a certain configuration where the tunnel comes in and actually goes uphill. So if you're interested in the specifics on that, call me and I'll show you some diagrams as to how it works because it gets a little bit involved.
All right, thank you. Okay, we're down to our last 3. Let's see. What happens? What if it fails and it starts to flood? Is it possible?
If the tunnel fails and it starts to flood, I mean, put it this way. In general, this has been engineered for years, and there have been lots of structural and other engineers who've looked into this. Obviously, we're putting people into this tunnel to build it. We feel it's very safe. We have specialized design consultants who only design or primarily design tunnels who've designed this. We have a contractor who also has years of expertise building these, so we don't foresee any issues like that. And we're always thinking to minimize any kind of risk, but we don't foresee anything like that, given all the due diligence that's been done.
Thank you. All right, these next two questions, they're the same question, but it says, what will happen to the old tunnels once construction is complete?
So the idea is once this new tunnel is built, all the flow from those two old tunnels will be diverted into this new tunnel. So the old tunnels will be dried out. And then district and other personnel will go in and inspect them. And as was discussed earlier, they've never been inspected. So we'll see what the state of those tunnels are. Perhaps some decision may be made to retrofit some of it, but that decision will be made once the tunnels are dried up and inspected.
All right, that was your last question, Russ. Thank you so much. You were a trooper, and thank you to everybody who stuck around for the presentations. Russ, before we go, maybe put your email on the chat so that way people have a way to contact you. Thank you so much.
Okay, thank you very much, everybody.
Thank you so much. That will be the end of our broadcast. Everybody have a great day.
Thank you.